As we move into the informal part of the meeting, we are pleased to present to you a short video showing live demonstrations of 4 of the company's products in action. POET's Senior VP, Dr. Mo Jinyu, explains why these products are so innovative and why we should all be excited about what we've accomplished and what's ahead for the company. Following the video presentation, Dr. Suresh Venkatesan will address all present here today. His address will be followed by a question and answer session. If you have a question or comment, please submit it through the Lumi meeting platform by clicking on the message icon. Please reserve all your questions until the conclusion of the presentation. Please enjoy the video.
As you can see here, this is the POET optical engine at the transmitter side. So in this chip actually is an integrated TX and RS chip. For all 4 channels, the I margin is more than 10%, and some of the channels actually are more than 20%. And this channel, at the moment, the I margin is about 24.5%. This single chip integrated 4 set of 100G LR4 receiver. Light is coming from the transmitter optical engine, go through a 10 kilometer single mode fiber, then the light is received by the receiver optical running, the error count is 0. We have pre-tested this system, all 4 channels. In this application, the error count is 0 and fully meeting the MSS spec. This is the transmitter chip. This picture shows a better view about this chip design, which consists 4 flip chip bonded DML lasers on the interposer. We are able to achieve excellent results on ER and the TXQ across the whole temperature range, which is from 0 degrees C to 75 degrees C. The TXQ value is between 1 dB to 2 dB, which is an excellent performance. This screen shows the current I that running from the live system at the moment. The ER is about 3.8 dB and the TXQ is about 1.69 dB. This is the receiver optical engine. This is the picture about the chip design, which consists of flip chip bonded PD array. And this is the pre-tested result from this chip, which shows we have excellent margin, the whole temperature range from 0 degrees C to 75 degrees C. Light is coming from the TXOE, transmit over a 2 kilometers fiber, then received by the receive engine. And as you can see that across the 4 channel, the BER is about e to the minus 6 to e to the power minus 8, which is a very good performance. These live demo systems are able to fulfill the 200G FR4 system requirement. we are demonstrating a two-chip solution which have one light bar chip and one modulator chip. Consists 4 high-power CW lasers flip chip bonded on the interposer. If we drive the laser at 300 milliamp, each of the laser will be able to output 30 milliwatt power. The second chip in the transmitter is the lithium niobate modulator. From channel 1 to channel 4, the theta Q is less than 2 dB other than the channel 3. This modulated light will come through the fiber transmission, then goes to the 400G RS receive chip. This is the 400G RS receive chip design, which consists 4 flip chip bonded 56G PD. For the back-to-back and up to 2 km transmission, there's no obvious penalty throughout the 4 channels. In this eye, the theta Q number at the moment is 1.77 dB. Transmission result up to 2 km, and at this moment each channel is running about with noise floor of e to the power minus 6, which is an excellent performance with such integrated photonics solution. This is the integrated chip developed by Poet. So it consists of 4 of them. Each set is the 400G FR4 application. We have developed such a EBB, a 400G reference transmitter, and the light coming out from here go through a 2 kilometers fiber and is received by the Poet integrated chip here. This is a result that we pre-tested. These are 2 sets, which is 8 channel result. The BR sensitivity curve provides enough margin against the MSA spec. After more than 19 hours of running, the noise floor is about e to the minus 7 to e to the power minus 6, which is well meeting the application.
Wow, that was exciting. Really can't wait for the CIOE to take place in December, where we will be able to actively showcase our solutions to the large and growing market in China. If some of you dialed in earlier or had the chance to see the interview with Vivek, he spent quite a substantial amount of time in China a couple of months ago. And reported on the progress that we're making in that market. A little more than 18 months back, we first introduced our optical interposer-based solutions to the world with 100 gigabits per second CWDM. Those products are now in the commercialization phase. In 18 months, we have leapfrogged from 100 gigabits per second and are now demonstrating solutions at 1.6 terabits per second. It's unprecedented for a team our size. I mean, we are at the cutting edge of what data communications speeds and bandwidth are asking for. It points to the simplicity of what it is that we have developed, with our optical interposer. That is our fundamental innovation. We're still the only company espousing and demonstrating a wafer-level chip-scale packaging solution for photonics. We do that with a proprietary waveguide architecture that sandwiches optical waveguides in between electrical waveguides, creating a unique architecture that addresses all of the various parameters that matter, that people actually don't talk about, but we're public about having solved issues associated with mechanical, electrical, optical, thermal challenges associated with such solutions. That's what makes our interposers ubiquitous in terms of being able to support the requirements of multiple markets, starting from DML lasers, where we're the only in a chip-on-board configuration, to other applications and other market verticals. By making our interposers completely CMOS compatible, we're able to leverage the broad semiconductor ecosystem to continuously add new capabilities to our interposer that allow us to scale from 2D packages to 3D architectures, and that provides competitive solutions, architectures, and form factors for alternate vertical markets as well. The hybrid assembly of components on the optical interposer converts the interposer into an engine. The engine is, of course, the key building block for modules that then support various applications. Over the course of this past year, we've added prototyping capability for engine assembly, both in our offices in Allentown as well as in Singapore. This is, of course, in addition to the larger scale assembly capability at our joint venture in Shenzhen. This is what allows us to, on the one hand, commercialize our existing solutions with our joint venture partner, but on the other hand, develop new capabilities, new technologies, new products for the growing marketplace of photonics applications. Touching on our key accomplishments this past year, they fall along four broad categories. First and most important, of course, are our path to commercialization. Over the course of this year, we completed alphas and betas and customer samples of various products. As Vivek talked about, 100, 200 gig FR4, 100 gig LR4, 400 gig FR4 receivers to various customers. We received feedback from them. In many cases, we had to make some changes to enable these engines to be utilized in modules. But those changes have all been incorporated into production designs. And these production designs are currently running at our foundry in Solterra. There are 4 projects with customers in active design targeting production in 2023. And we expect to be doing a product release, 4 product releases by the end of this year and 4 product releases in the first half of 2023. That is a lot of work on a small team, but the simplicity, logic, and the work that we've done over the past 3 or 4 years that all of you have been familiar with has allowed us to get to this point where we're now able to generate these products and release them with some regularity and predictability in our delivery schedule. So these products, from a commercialization perspective, are in the final phase, which is reliability and qualification, prior to, of course, product release. Our transfer of technology to SPX, which Super Photonics, is complete. And second-of-a-kind tools that have been established at Super Photonics for manufacturing. We're also on track to deliver alpha samples for our C-band light engines, which is an active engagement with Celestial. We also have other active engagements in the space. In addition to the path to commercialization, it's really critical for us to continue to enhance the capability of the interposer because that is required for the new applications coming downstream. To that end, this year, we prototyped for the first time co-integration of electronics with our interposer. We're now, for new products, integrating merchant transimpedance amplifiers as well as laser drivers onto our interposer for advanced applications in 800G solutions and beyond. Another really important piece of work that we did this year, and if you guys have followed our story, right, you've known that we were, to a certain extent, dependent on the availability of components for 400 gig. So it was really important for us to expand the capability of the interposer to not be captive to just a few providers. And we did that over the course of this year that allows us to broadly adopt laser solutions from multiple providers that then gives us multiple sources for the new solutions that we've got to deliver. In fact, just this week, we received our first lasers from Broadcom, and we're incorporating that into our interposer, something that we could not do a year ago. We're also incorporating through silicon vias into our interposer, which is another very critical capability that is necessary for 1.6 terabit per second architectures. So this allows us, this is what I talked about before, which is, enabling the semiconductor ecosystem to work for us, right? By enabling new capability onto the interposer while still simultaneously delivering the competitiveness that we can offer. We also have new product designs that we accomplished in 2022. One of the gaps that we had in our roadmap was the transmitter for 400 gig, and we're really happy to have demonstrated this. As you saw in the video, we've been working with a vendor on thin film lithium niobate. They have a modulator that's showing excellent performance, and simultaneously, we're also working on products with the directly modulated lasers. We have a verbal commitment on getting these lasers. We've actually tested them, validated them on our interposers. They look great. We should be getting those lasers by the end of this year. And we've completed our design. In fact, silicon on our 400 gig, 800 gig, and 1.6 terabit products starts next week at Silterra. So this is a major accomplishment for us. I mean, we now have 2 pads to 400, 800, and 1.6 terabits. One using a novel capability with thin film lithium niobate, which is then scalable to 3.2 terabits and beyond, and one using directly modulated lasers, for which, of course, we have a lot of experience, 2 or 3 years of working with directly modulated lasers. And we're really excited that, we've been able to accomplish this actually this quarter. And you can see on the right-hand side of the chart, those are what the designs actually look like. This is not PowerPoint, this is not words, this is actual designs that are running in the foundry that allows us to be a lot more predictive with our schedules in terms of being able to provide samples. One of the things we did, which I believe leapfrogs the competition, is we've architected our engines to be chiplets. Chiplets is a very common term in semiconductor electronics these days. I think we're the first people to really talk about it in terms of a practical application in pluggable modules. So we've designed specifically these transmitters as 400 gig chiplets that can be either doubled or quadrupled to generate 400, 800, and 1.6 tera, all with the same solution. Another very important point with regards to predictability of our schedules is the fact that the DML laser providers that we're working with are going to be providing us with qualified lasers. This is not what we had to deal with the Sanan or even with DenseLight before, where because we were making custom lasers, we had the burden to first qualify the laser, which is 5,000 hours or 6 months, and then qualify it on the engine, which is another significant period of time that adds a risk and cost and schedule. Whereas now, because of our ability to have modified the interposer to use more commercially available solutions, we're able to get a little bit more predictability associated with our schedules there. We've also done product designs at 800 gigabits per second and 1.6 terabit per second on the receivers, which is also includes integrated transimpedance amplifiers. And we will have samples of these solutions in the first quarter of 2023. And as you saw in the demonstrator, I mean, a thin film lithium niobate based 400 gigabits per second solution that we demonstrated is a novelty, and we're very, very happy to have been able to do that. And we are, as Vivek had mentioned, working hard to get samples in customers' hands over the course of the next 6 months. The other major piece over the year is industry recognition. I think Vivek talked about the fact that we're now being recognized in the industry, and I personally have provided accepted papers into very, very fancy conferences, VLSI, PIC, ECOX, Synopsys Photonics Symposia, and we're being invited to give talks, or we've been invited to provide our slides into workshops on, how integration or co-integration of photonics and electronics using the general concept of photonics interposers can really advance the state of the art. So those are the accomplishments that we've had over the course of this year. It's been a very busy year. We predicted that it would be a very busy year. We did have some delays especially on the 400 gig TX, largely driven by the availability of components, in particular the modulator. But we've now solved that, right? We now have two sources of modulators that we have proven that works. One is the lithium niobate. You saw it yourself in the demo. And the other is, of course, the directly modulated laser solutions. So our business is, pursues three tracks. One is enabling the solution for 800 gig through 3.2 pluggable modules. We believe that with POET's technology, we can actually extend the life of pluggable modules all the way to 3.2 terabits per second, largely driven by the integration capabilities. You can see here, these are actual live module pictures that we have worked with the module partner to design. And these are receive and our two transmit chiplets to form an 800 gig solution. And you can see just how small it is. I mean, they fit readily inside of an OSFP XT with a lot of room to spare. So this is, one key track for us. And we believe that, once we have this solution validated, which is imminent as we have completed our design and it's now running in manufacturing, we can then leverage this at 400 gig for cost reduction and as well leapfrog to 1.6 terabits per second as well, because the same solution is fundamentally extensible. And I think that's the beauty of what we've been able to do, is that we've kind of architected a solution that, a single solution advances, quite significantly the roadmap in this space. The second vector that we are progressing our business around is light sources. As you all know, we've got a contract with Celestial. We're also talking to several other potential customers that need light sources. And these are for AI ML accelerators. And I think while there's a lot of hard evidence in terms of data communications, and there are a lot of people in that space, it's also a very crowded space. This one is a little bit more blue ocean in terms of what POET can provide relative to what the market needs are. And this market is, in fact, expected to be quite large, right? So even a single customer like Celestial might project, for example, 1 million units of sales from their perspective. And if they do that, it's 4 times that in terms of light sources. And you can just do the math. These light sources with 8 lasers that are co-integrated onto an interposer, are easily going to be in the triple-digit dollars. And we are on track to deliver the first set of samples at the end of this year. Production would be next year. And then the revenue ramp in 2024, but when it does ramp, it's going to be big, right? And especially with the potential of some new customers being added in the space. The third major vector for us is the new materials path, and we're happy to announce that with thin film lithium niobate, it's had a lot of advantages in terms of bandwidth and low power consumption, but it has lacked integration capability. We've been able to partner with the provider. We bring the integrated solution capability to lithium niobate. So the optical interposer has that unique capability, which is to breathe integration potential to novel materials, which otherwise may not be integratable into these pluggable modules. And so this is an example of our solution that we are now taking into manufacturing. It's running at the foundry today. But this is our interposer solution based off of integrated lithium niobate. So we've got 2 paths to 400 gig. And both are now predictable paths because they've both been validated in terms of performance already. And we're very happy that we've worked really hard over the past 6 months to get here and have made this kind of progress now. In fact, the delay that we had allowed us to actually not be just myopically focused on 400. It allowed us to actually architect a platform solution for 1.6 terabit and derive 400 from it, right? And so that really allows us to leapfrog in terms of where we want to go. So on our product roadmap, I mean, no changes. I would just highlight that the first few line items there are, legacy in the sense that, customers already have solutions in that space, and we're trying to intercept with a lower cost solution or potentially a higher performance solution for redesigns. Whereas the last products or last three line items are completely new. In terms of transmit and receive solutions, as well as light source solutions that are transcend where the industry is today. So if I just systematically walk down the list here, so 100, 200 CWDM, Vivek talked to you about the product release that we intend to do. We've got 4 active design-ins working closely with customers. They have incorporated our solutions into their modules. And they've given us feedback on things we have to change. And that is kind of the iterative nature, unfortunately, and when you're providing an optical engine, is we have to do all the validation at the engine level, then they have to do the validation at the module level, and those two go serially. And it might be painful for you guys watching us and wondering what's going on, but that is unfortunately what the design process looks like. At 800 gig and beyond, we POET are going to take a slightly different path where, in addition to, of course, working with customers or module vendors on engines, we would expect to make modules ourselves. And we believe we know our engines better than anybody else, and therefore, we can do a parallel bring up of the module with the engine development, really cutting that cycle time quite substantially down. And we think that that's really the right path for us going forward. So we will be, making that change in our strategy that we had publicly announced a few months ago. On LR4, of course, we've got an active design in, multiple customers in an eval stage. LR4 is an interesting market. It's got another 10 years of life. There's clearly a need for cost reduction, and we are the only ones to provide a chip-on-board solution on LR4. In these instances, it's really important for us to complete our product release. I was giving an analogy previously about, if somebody comes out to you and says, "Hey, I found this new spring and I'm going to be bottling water in 6 months," you're going to tell them, "Well, bottle it, put it on the shelf, and I'll consider buying it." And I think in some of these legacy products where, it's already running in very high volume, people are going to look for us to put product on the shelf. I mean, and that's where this product release becomes extremely important, because nobody is going to commit resources unless they know that it's kind of available, right? And so we are working hard to release the products while at the same time continuing to engage with the customers to make sure that it meets their requirements and needs. So we are confident that this platform is going to get commercial traction next year. As Vivek said, he's had fantastic meetings even with telecom companies in China that are very keen to evaluate our solutions when available for that market segment. So in these areas, we're I think the commercial success is starting to take root, and we're very happy about that. And of course, for 400 gig, the receivers are being tested, and I think once we have the transmitters in first quarter of next year, then they would basically get designed in together. People don't want to do a complete redesign just for our receiver, right? So they want to be able to pair it up with our transmitter. And so, we're happy to announce that we now have a path to doing that, a very, very, very credible path to doing that. And we're excited about that. On the light sources, we've got an active design in, an active evaluation of our solutions. And of course, this is a burgeoning market, right? There are a lot of people that are slowly getting into this market for light source engines. And we believe we have a very good solution in that space. And then we also have a lead customer win for our 800 gig receivers with integrated TIAs. And we'll be sampling that in Q1 of next year. So we're happy to announce that. I mean, I think it's not just about the technology, it's about the products. It's about the products that customers want. It's about the products that customers are going to use. And, you know, we've really been setting ourselves up for this success over 2022. And we expect to be in production in 2023, you know, 4+ years after we started development on the interposer. So I'm pleased at where we are, and I'm pleased at the activity the team has put in through these challenging times, of course. And I also want to thank you for your time and attention and for your enduring patience. But we are in a good place. Thank you.
Okay, thank you, Suresh. Really appreciate the presentation. And at this point, we want to open the floor up for questions. We do have some questions coming in through the platform. We've advised everyone to put their question there through that platform. So we will start off with questions. Tom, do you mind starting off with the question here that seems to be targeted to Vivek?
Yes, thanks, Kevin. We have several questions around the same sort of theme, and this is a question for Vivek. To some extent, Suresh just covered some of that with respect to customers, but the question is around the fact that we've referred to, you know, contracted or committed engagements. And so the question is, how have the number of engagements evolved or increased over the year? And what's our expectation for seeing revenue related to the products?
So thanks, Tom, for reading out the question here. I would like to bucket the customer engagements into three categories or three buckets. So one is the currently contracted customers, which we've shared, you know, in announcements and presentations, etc. We have 6 opportunities that we are working actively on, and we are very committed. So it's not. So actually, let me go through the three categories. The second one is the standard products that evolve in connection with these contracted customers and which are on our roadmap that Suresh showed earlier, which we've been showing also previously. So there it is more, we would call it standard products that we can go to a wider customer base that could use it. There may be certain tweaks and all, but essentially standard products. And the third one is more strategic engagements, where customers either want some customization or advanced generation products where they see the value of our interposer platform integration technology. So on the first one, we are very committed. So having the contract is not the end of the road, it's actually the beginning. We want to make sure the hard work that we've done, our customers have done to arrive at that contract, that we execute seamlessly, we execute efficiently on it and work hand in glove with our customers. So there's a lot of focus on that, and we continue to do that. At the same time, as we are rolling out the standard products, 4 of them getting into mass production or product release by end of the year, another 4 in the first half of 2023, we continue our engagements. We have multiple design-ins, active design-ins with module customers in China that we are working on, and they are designing in our products. So those we would expect, or we plan to get into supplying to our customers in the early part of next year, get POs and start shipping products, as I mentioned in my video also, and expand that customer base as we continuously do so with multiple engagements with these standard roadmap products. And the third one is the strategic engagements, Now we have to be selective about, there's many opportunities or customers come when they know a lot about POET's optical interposer platform, and with the various conferences and engagements. So there's multiple inquiries that come in, but we have to be very selective. We have to make sure that it aligns with our strategy. We have to make sure we have it resourced well, and many things go on. We don't want to take up everything on ourselves and not deliver to the expectations. So here we have, I would say, very realistic and active engagement that is going on. I can say three on top of my head that I know that is very active on strategic engagements where customers want certain customization, and then ultimately with the goal of developing the product and going into product. So in summary, that's really, I think my intent was to summarize where we stand in terms of customer engagement here. Tom, does that?
Okay, yeah, thank you very much, Vivek. I'm going to go next to Suresh. Suresh, we have a question here about our North American Tier 1 that I think we announced an engagement with almost 2 years ago, at least, I think. And the question revolves around, what's the status there? And question about whether they wanted a specific laser for that application, and maybe you can shed some light on that question.
Yeah, we had an engagement some time ago, and I would say it was part of a development agreement to create some remote light sources. The architectures have changed over a period of time. The industry MSAs have changed over a period of time. We continue to remain in dialogue and conversation, especially as we develop our new products. And I believe that their familiarity with what our technology has done and is capable of doing allows them to constantly look at potential intercept opportunities. And we believe that there are still opportunities, especially in the new products. I mean, for most of the North American companies, it's very different from in China, right? China is primarily 100, 200, 400. North America and Europe is 800 and beyond. And now, thankfully, we have solutions that do span the globe. And we think that these new opportunities will reopen with the advent of our chiplets, which is in itself quite novel in terms of how it's implemented. So I am hopeful that we can reopen some of those doors from the past.
Great. There are a number of questions that I'd like Kevin to relate since they're or ask since they're related to some of the financing issues of the company. So Kevin,
Sure.
Can you take that?
Yeah, sure. So there are a few questions we have coming in here, and I've noted most of them are actually tied to kind of the same thing, which revolves around our expected our cash position and any concerns about raising capital to fund the company in the near future.
Okay, so let me take that first of all by saying that we haven't published our Q3 results yet, so the only thing I can do as far as our cash balance is concerned is relate it to the June 30th number, at which time we had 13.8 million in total cash, and our cash burn per month has not changed very much over the course of the past year, and so we expect that to continue at about the same rate going forward. As far as capital raise is concerned, we're looking at several alternative means of raising capital. It's not possible for me to be specific But I can say that if we raise capital through equity, we will try to minimize the dilutive impact as much as possible. You know, we are aware that the current stock market environment is rather volatile, especially for microcap technology companies. There have been very few follow-on financings for microcap technology companies, actually since Q4 of last year. And we look at those statistics all the time, and we are speaking with bankers about it. But we do have alternative means of raising capital. And so over the course of the next several months, we'll be able to be more specific about that. Kevin, are there any other questions in the finance area?
No, nothing else in the finance right now, but as they're coming in, I'll pass on to you.
Any other questions, Tom?
Yeah, there's one here about analysts. It's when do you anticipate that major institutions, recognized analysts, will get involved in buying into Poet? And the answer is one of our main objectives of listing on the NASDAQ was to acquire some coverage by respected analysts. In fact, we are covered by Richard at Craig-Hallum. And he's very well known in this field. And we have some other banking buy-side analysts, or sell-side analysts looking at covering us. We're also covered by Zacks, and we do participate in a number of conferences that are given by various banks, both pay for play and not. And so there are a number of other analysts who are very familiar with what we're doing. It's a matter of them covering us. So that was one of our main objectives. And you know, it's a requirement to be covered first before you really get any traction with institutional investors. So if there are any other questions coming in, we're happy to take them. Suresh, we have no other questions.
Okay, awesome. All of you, thanks for your time. I know, you know, we're getting up on the hour, so I appreciate your attention, your participation, and looking forward to additional communications with you as we continue our march towards disrupting the ecosystem. Thank you again, and thank you, Peter, as well, for you know, conducting the AGM this year, and look forward to seeing all of you all in person, hopefully next year when things you know, get back to normal, I suppose. So that's it from me. Thank you.
Thank you, everyone, for being part of this meeting. And as Suresh mentioned, we look forward to seeing you all, and we'll continue to keep you posted on the progress of the company. And again, we encourage everyone to please stay safe, and until next year.